A young man walks into a doctor's office. He walks out with an expiration date. 2 years. That's the whole sentence. 24 months to settle his affairs, hug the people he loves, and make peace with the fact that it's over before it ever really started. Now jump ahead half a century. Same man, still alive, still working, still staring into the darkest objects in the universe and dragging their secrets back into the daylight. He pinned down the exact moment the universe was born. He proved that black holes glow. He forced two theories that had despised each other for 100 years to sit down and shake hands. And he did every bit of it locked inside a body that kept switching itself off. He couldn't walk, couldn't lift a spoon. In the end, he couldn't speak or breathe on his own. One blazing mind, sealed inside a cage of flesh that shrank around it a little more every year. This is Stephen Hawking, the man who didn't just crack the laws of physics wide open. He skipped his own appointment with death, and then kept skipping it for 45 years longer than anyone believed was possible. Stay with this one. The way he pulled it off is stranger than anything a screenwriter would dare invent. Rewind to where it almost ended. He's 21, barely an adult, sitting across a desk from a doctor, hearing a phrase he's never heard before. Amyotrophic lateral sclerosis. ALS. It sounds like clinical noise. Behind those letters sits something far worse. Here's what the disease actually does. The wiring that tells your muscles to move, the motor neurons, starts dying off, one strand at a time. First you trip over nothing. Then your legs quit. Then you can't hold a cup. Then you can't speak, can't swallow, can't breathe. No cure. Nothing that stops it. Just a slow fade to black. And the cruelest part of all? Your mind stays razor sharp the whole way down. Awake, aware, watching from inside a body that's turning into a coffin. The doctors didn't dress it up. 2 years, 3 if he was lucky. Go home, son. Say your goodbyes. Let the dreams go. And this kid had dreams the size of galaxies. He'd just started his PhD at Cambridge. He wanted to crack the biggest question there is. Where did all of this come from? The stars, the planets, the galaxies, life itself. How do you get everything out of nothing? Picture finally catching the thread that might lead to the answer and being told the finish line sits a few steps past the starting gun. So he broke. Deep, black, airless depression. Why finish a dissertation you won't live to defend? Why plan anything at all? He drank. He stopped working. He shut the door on everyone. The story of a genius looked like it would end before the first real chapter got written. And then something happened that no equation saw coming. He fell in love. Her name was Jane. And here's the part that still stops people cold. She loved him back. She didn't run from the diagnosis, didn't treat him like a man with a countdown clock stapled to his chest. They got engaged. They married. And Hawking said it flat out years later. That changed everything. Suddenly there was a reason to keep going. Suddenly there was a future again, even if it might slam shut at any second. Now watch the strangest turn of all. 2 years passed, then 2 more, then more. The disease kept advancing. A cane, then a wheelchair, then no more handwriting. But it crept forward far slower than anyone had predicted. And while the body powered down, the mind spun up, faster, sharper, like a machine that gets more precise the more you strip away from it. So he went back to the question that started the whole thing. Where did the universe come from? And to answer it, he'd have to pick a side in a fight that was tearing physics in half. The early 1960s, the field had split into 2 camps. One camp said the universe was eternal, no beginning, no end. It simply always was and always will be. Unchanging, comfortable. The other camp said something that sounded flat out insane. Once, there was nothing. No space, no time, no matter. Absolute emptiness. And then, everything. All at once. Out of a point smaller than an atom, the entire universe erupted, like a firework unfolding into being. They called it the Big Bang. But how do you get something out of nothing? It shreds every rule of common sense. Plenty of serious scientists just rolled their eyes. Young Hawking decided to find out who was right. And his first breakthrough came from the side, out of nowhere. He sat in on a lecture by a mathematician named Roger Penrose, and what he heard rewired his brain. Penrose was talking about black holes, those cosmic monsters that swallow everything, even light. But the interesting part wasn't the black hole itself. It was what sits at the dead center, a singularity, a point where the laws of physics simply shatter, where space and time stop meaning anything at all. Hawking sat there assembling the puzzle in real time. Look at the logic. A black hole crushes matter inward, squeezing it down to a single point. Everything vanishes into it. So what if you ran the film backwards? What if instead of swallowing, that same point spat everything back out? That was the moment of pure genius. If a black hole is a place where everything falls in, then the Big Bang is a black hole turned inside out. Same kind of singularity, but instead of devouring, it erupts. Out of that one point came all the matter, all the energy, all of space, all of time. The whole universe fired out like a shell from a cannon. He took Einstein's relativity, bolted on Penrose's math, reversed the arrow of time, and proved it. The universe had a beginning, a moment of birth. Argument over. He was 26. By the doctor's math, he should have been dead for 5 years. Instead, he'd just rewritten cosmology. And the disease? It kept coming. His legs were gone for good, his hands were weakening. But stopping was never on the menu, because a bigger question was already burning in him, and it leads straight into the next fight. The universe was born from a singularity. Fine. But why? What lit the fuse? What pulled the trigger on creation itself? To answer that, Hawking had to do something nobody had managed. Get the two greatest theories in physics to work in the same room. On one side, Einstein's general relativity, the theory of the enormous. It explains gravity, planets, stars, the way space and time bend. It runs the universe at the grand scale. On the other side, quantum mechanics, the theory of the tiny, atoms, particles, the flickering subatomic world. And here's the problem. These two can't stand each other. Try to use both at once and the math collapses. The universe stops making sense. But at the instant of the Big Bang, they had no choice. They collided head-on. All of reality crushed into a point smaller than an atom. That's quantum turf. And the gravity there was monstrous. That's relativity's kingdom. So how did they work together? Hawking went back to his favorite laboratory. Black holes. Relativity says nothing can exist at the edge of a black hole. Everything gets dragged in. But quantum mechanics says something else entirely. Empty space is never really empty. Even in a perfect vacuum, something is always happening. Right now, everywhere around you, tiny pairs of particles are blinking into existence and vanishing again. One with positive energy, one with negative. Born from nothing, alive for a sliver of an instant. Then they smash together and cancel out. Physicists call them virtual particles. This isn't a hunch, it's measured fact. Hawking was 28 when it hit him. What happens if one of those pairs pops into being right at the edge of a black hole? Then the magic starts. The negative energy particle falls in. The positive one escapes and becomes real. It flies off into space as radiation. Which means, hang on, black holes leak. They give off radiation. They aren't perfectly black at all. When he announced it, the room laughed. Black holes, by definition, can't emit anything. It's right there in the name. But Hawking was right, and he'd proven something far bigger than a faint glow. He'd shown that gravity and quantum mechanics can cooperate. Gravity yanks the negative particle in. Quantum mechanics lets the positive one slip out. The two old enemies had finally found common ground. They named it Hawking radiation. The kid who was supposed to die at 23 had, at 28, carved his name into physics for good. And it cracked open a door onto something even stranger. Follow the thread. If a black hole radiates energy, it has to be losing something. It has to lose mass, which means a black hole must slowly evaporate. Over billions of years, it glows like a dying bulb, burning itself away, smaller, then smaller. And as it shrinks, the radiation intensifies. The whole process speeds up, and at the very end, boom, the black hole detonates with the force of millions of hydrogen bombs. That's when it clicked for Hawking again. An explosion out of a tiny point. That's the Big Bang in miniature. What if studying how black holes die could teach us how the universe was born? Beautiful. Also completely theoretical. Nobody had ever seen an exploding black hole. Nobody had detected Hawking radiation. It was gorgeous math on a chalkboard and nothing more. Where was the proof? Fast forward a few decades, 2008. NASA launches a special telescope named Fermi. Its job? Sweep the sky for gamma-ray bursts, the most violent radiation in the universe. And if Hawking was right, if tiny black holes really do explode, they'd announce themselves with exactly that kind of flash. Somewhere in the chaos up there, buried under gamma rays from supernovae and pulsars, there might be one signal. A dying black hole gasping its last breath, exactly as Hawking predicted. Find that signal, and you prove the genius right. Keep that telescope scanning in the back of your mind. We'll come back to it. Because Hawking's own body was about to hit its darkest hour. By the late 1970s, his body had almost quit. He couldn't walk, could barely move his hands. His speech was slurring into something only the people closest to him could decode. But the work never stopped. He dictated papers letter by letter, word by word, an agonizing grind. He refused to fold. Then, in 1985, on a trip to Geneva, catastrophe. He caught pneumonia. Severe. The kind that kills. Doctors performed an emergency tracheotomy, cut into his throat and slid a tube in so he could breathe. It saved his life. It also took his voice for good. The last thread tying him to the spoken world, cut. Sit with that horror for a second. You're one of the greatest minds alive. You've got an entire universe of ideas in your skull. Discoveries, theories, whole new physics, and you cannot make a single sound. Not one word. Sealed inside your own body with no way to reach another human being. That's worse than any prison. His family was terrified. His colleagues thought that was the end of it. And then, thousands of miles away in California, an engineer named Walt Wolters got a phone call. There was a physics professor at Cambridge who needed help communicating. Wolters had already built software for exactly this. He'd made it for his own mother-in-law, who had ALS. He asked, half guessing, "Is this Stephen Hawking by any chance?" They wouldn't confirm it. So he said, "Tell you what, if it's him, I'll do it for free." It was him. Wolters's program, called Equalizer, let Hawking pick words and letters from a database, and a synthesizer built into his wheelchair spoke them out loud. He still had a little movement in his hand, so he used a clicker. Letters and words scrolled past. The software guessed what he wanted, and he chose with a twitch. Slow. Brutally, exhaustingly slow. Around 15 words a minute. But it worked. And out of it came the voice the whole world would come to know. Flat, mechanical, unmistakably American, unmistakably Hawking. He got so attached to it he refused to ever swap it out. "I keep it," he said, "because I've never heard a voice I like better." He'd risen out of the ashes with a new voice and a whole new life. He'd type, he'd joke, he'd needle people, and the ones closest to him swear they never once saw him show a flicker of self-pity. He just kept moving forward. Most people would have shattered under that weight. Not him. He got a second chance and he wrung it dry. And by now, the physics world was buzzing about a new idea so radical that half his colleagues were tapping their temples. The idea was string theory, pushed hard by physicists like Michael Green and John Schwartz. The premise sounds like a fever dream. Everything in the universe, electrons, quarks, galaxies, all of it, is made of unimaginably tiny, vibrating strings. Picture a guitar string, but a trillion times smaller than an atom. Pluck it one way and you get an electron. Pluck it another and you get a quark. Another, and you get a photon. The whole universe is one enormous orchestra of microscopic strings. Sounds like nonsense, but the math was flawless. And better than that, string theory promised the exact thing Hawking had chased his whole life. It could fuse gravity and quantum mechanics into a single frame. It could be the theory of everything. There was a catch. For the math to close, the universe needed something impossible. We live in 3 dimensions: length, width, height. Add time and you've got 4. But string theory insisted there are at least 9, maybe more. And you're already thinking, hold on, we'd notice extra dimensions. Where are they hiding? Here's the truly bizarre part. They never went anywhere. They're curled up, twisted into knots so unfathomably small that we can't see them. Think of a garden hose from far away. Looks like a one-dimensional line. Get close and it's obviously 3-dimensional. Shrink down to the size of an ant crawling along it, and there's a whole extra direction to move in that you never knew was there. And Green and Schwartz argued those curled-up dimensions actually shape our universe, starting with a mystery that had nagged at physicists forever. Why is gravity so ridiculously weak? And yes, gravity is weak. Think about it. A cheap fridge magnet holds a sheet of paper up, beating the pull of the entire planet Earth. The whole planet yanks that paper down, and a little magnet says, nope, and wins. Why? Because right after the Big Bang, something strange happened. In the first instance, all the forces of nature were equally strong. Gravity, electromagnetism, the nuclear forces, all on level footing. Then the universe expanded, and gravity suddenly went weak. String theory's answer? Gravity leaked away into the extra dimensions. Imagine music playing loud, right next to you. Walk away and it fades. Now imagine there are even more directions for the sound to spread into. It thins out even faster, gets even quieter. That's what happened to gravity. It smeared itself across all those hidden dimensions and went faint. And that, it turns out, is why we're alive at all. If gravity had stayed as strong as it was at the Big Bang, the whole universe would have collapsed back into a point in a fraction of a second. No stars, no planets, no us. Hawking watched string theory with real admiration and real suspicion. He loved its elegance. He did not become a believer. And he was right to hold back, because the theory had one enormous flaw, not a shred of proof. Beautiful equations, 0 experiments. So how do you test a universe made of strings? That's where the most ambitious machine humans have ever built walks onto the stage, the Large Hadron Collider. A monster buried under the border of Switzerland and France. A ring 17 miles around, packed with superconducting magnets and detectors. The idea is insanely simple and insanely hard at the same time. You accelerate subatomic particles in opposite directions, almost to the speed of light. Then you smash them head-on with staggering energy. The collision recreates the conditions that existed a heartbeat after the Big Bang. Put another way, humans decided to fire up a tiny replay of the birth of the universe right here on Earth, under Geneva. The goal? See what gets born in that primal chaos. Watch how the pieces behave, and maybe, just maybe, catch the extra dimensions string theory predicted. How? If those dimensions are real, gravity at very small scales should suddenly get strong. Strong enough that when particles collide, something incredible could happen. Matter could collapse into a microscopic black hole. You heard that right. The collider could become a black hole factory. Churning out black holes smaller than a proton, but real black holes all the same. And people lost it. Social media melted down. Scientists are building a black hole. It'll eat the Earth. We're all going to die. The conspiracy crowd dusted off their old files and polished them to a shine. Lawsuits, protests, petitions to shut it down. But the physicists at CERN were leaning on Stephen Hawking. His theory was the thing that would save the planet. Remember Hawking radiation? Any tiny black hole would evaporate almost instantly. It would flash like a spark and vanish in a fraction of a nanosecond. No danger. The opposite of danger. If one appeared, it would be a triumph. First, it would prove extra dimensions exist. String theory wins. Second, it would confirm Hawking radiation. The genius was right. Third, we'd watch a black hole born and die with our own instruments. The science story of the century. The first run was set for late 2008. Hawking was 66 by then. 66. Let that land. The kid handed 2 years at 21 had made it to 66. He'd cheated death by 45 years. But death doesn't nap, and the story cuts right here back to his body. Every year got harder. First his fingers failed, and he started steering the computer with a twitch of his cheek. Then even that got difficult. He moved to a sensor that read the smallest movement in the muscles of his face. In the end, there was a single channel left between him and total silence. One small muscle near his eye. One muscle. That's what stood between one of the greatest minds on Earth and being cut off from the world completely. But he kept working. Slower. Far slower than before. Still working. His daughter Lucia said the family lived in constant fear. Every cough, every infection could be the one. You never knew what would finally snap that thin thread. And then, the moment everyone was waiting for. September 2008. The collider powers up. The world holds its breath. And the machine breaks. A serious, catastrophic failure. Launch delayed. Repairs would take months. Hawking waits. He has no choice. Time drips away. The body fades. But he waits. Because if the collider finds those extra dimensions, if it catches even one tiny black hole glowing with his radiation, then every decade of struggle and pain and stubbornness will have led to one word: proof. That's a long wait with the meter running. So what did they actually find? The collider finally roared back to life in 2009, and the grind began. Trillions of collisions, petabytes of data, scientists sifting for anomalies, for strange signals, for any hint of new physics. Did they find black holes? Not yet, but they found something else, and it was huge. The Higgs boson, the particle that gives matter its mass. Another piece of the cosmic puzzle snapped into place. And the Fermi telescope, still hunting exploding black holes? Still scanning, every day and every night. Gamma-ray bursts pour in constantly, from supernovae, from pulsars, from neutron stars slamming together. But the specific fingerprint of a dying black hole leaking Hawking radiation? Not found. Not yet. Does that mean Hawking was wrong? Not necessarily. Maybe these events are so rare we haven't caught one. Maybe our detectors aren't sensitive enough. Maybe black holes evaporate a little differently than the theory says. Science closes in on the truth one step at a time. Which brings us to the question that haunted him to the very end. Is there a theory of everything? One equation to explain it all, from quarks to galaxies, from the Big Bang to black holes. He chased it his whole life, and near the end, he reached a surprising conclusion. Maybe it doesn't exist. Maybe the universe is too rich, too many-sided, to squeeze into a single formula. Maybe we'll need a whole family of theories, each describing its own slice of reality. That's not defeat, that's honesty. It's admitting the universe might be more inventive than we ever assumed, that it doesn't owe us a tidy answer and doesn't have to play by our rules. But one thing he proved beyond argument: the human mind is capable of the impossible. A paralyzed man who couldn't move, speak, or breathe on his own reached into the darkest corners of the cosmos and pulled out secrets that had been hidden for billions of years. He found the moment the universe began. He proved black holes glow. He showed gravity and quantum mechanics can work together. And he lit a fire under millions of people, not just scientists, but ordinary people staring down their own impossible odds. His daughter said it perfectly. The thing she learned from her father was this: if you fall into a black hole, don't give up. There's a way out. That's exactly what he did with his life. Stephen Hawking died in March 2018. He was 76. 76, against the 23 the doctors had circled on a chart. 53 stolen years. The mind, winning against the body. They buried him in Westminster Abbey, between Isaac Newton and Charles Darwin. 3 titans who changed how we see the world, lying side by side. On his gravestone, they carved the equation for Hawking radiation. No epitaph, no last words. A formula, because that's where he found his immortality. His body died. His ideas will run for centuries. Here's the thought that stays with me. There's a thing in physics called the event horizon, the edge of a black hole, the line past which nothing returns. Cross it and you're gone forever. But Hawking proved that even from beneath that horizon, radiation can escape. Even from there, there's a way out. His whole life was a proof of that theorem. His disease was a black hole that, by every law of medicine, should have swallowed him whole. But he radiated genius, humor, an appetite for life. And that radiation broke free and lit up the world. He was one of two physicists every school kid could name, Einstein and Hawking. One reshaped our idea of space and time. The other showed us where space and time came from. But dig a little deeper and there's a gap between them. Einstein worked in comfort, in a healthy body, free to write and argue and think. Hawking did all the same work while completely paralyzed, speaking through a machine, composing at a few words a minute. Think about the patience it takes to write a scientific paper when every word costs minutes. Think about the will it takes to keep going when your own body is the enemy. He didn't just solve the riddles of the universe. He proved the mind is stronger than the body, that a person isn't their shell, but what's inside their head. And here's the funny thing. He refused to be a saint about any of it. Asked about his IQ, he'd say he had no idea, and that people who brag about theirs are losers. When journalists tried to turn him into a tragic martyr, he'd snap back that he was just a physicist doing his job. He hated being pitied. He didn't want to be a motivational poster. He just wanted to understand how the universe worked. But the effect was enormous anyway. Millions looked at him and thought, if he didn't quit, what excuse do I have? He wrote A Brief History of Time, one of the best-selling science books ever printed. Tens of millions of copies. And famously, hardly anyone finished it. It became a joke. The most bought, least read book in history. Doesn't matter. What matters is that people reached for that knowledge. They tried. He warned us too in his final years. About artificial intelligence, about climate, about nuclear war. Not as a doomsday prophet, but as a scientist weighing the odds. He pushed for us to get off this planet, not out of romance, but out of cold math. Too many ways to go extinct sitting on one rock. He also had fun. He floated weightless on a zero-gravity flight, arms spread, grinning like a kid. The man who spent his life studying gravity, free of it for a few minutes. He turned up on Star Trek and The Simpsons and The Big Bang Theory, playing poker with Einstein and Newton, cracking jokes at his own expense. He once threw a party for time travelers, sent the invitations out after the party so only somebody from the future could attend. Nobody showed. Either time travel is impossible, he concluded, or his parties were just too boring. He asked, right to the end, whether the universe even needs a god to explain it, and argued it could create itself out of nothing, because a law like gravity exists. Religious leaders bristled. He held his ground, careful to say not that God definitely isn't there, but that you don't need one to do the math. Nobody knows who's right, and he was fine with that. The biggest questions don't have easy answers, maybe no answers at all. But science isn't afraid to ask. So here's what he left us. Not a formula, not a theory, a dare. Remember to look up at the stars and not down at your feet. Try to make sense of what you see, and wonder about what makes the universe exist. Be curious. That's the whole inheritance. Be curious. Keep asking. Don't make peace with not knowing. Somewhere out there, millions of light years away, a tiny black hole may be dying right now, firing off its last photons of Hawking radiation and vanishing in a blinding flash. Proof that even from the darkest pit, there's a way out. And somewhere down here, a student is opening a physics textbook and reading for the first time about black holes, the Big Bang, and the paralyzed genius who figured it all out. And a new spark catches. The doctors said 2 years. He said, we'll see. The disease said, you're helpless. He said, hold my beer, I'm about to flip the universe over. Death said, your time's up. He said, you'll wait another 45. He didn't beat the disease. He couldn't. What he beat were the limits it tried to nail onto him. So now it's someone else's turn to choose what to do with the time they've got. Look up. The stars are still there. The mysteries haven't gone anywhere. And if anyone ever falls into a black hole, remember what his daughter said. Don't give up. You can get out. Maybe not your body, but your mind, your ideas, your spirit, those are stronger than any gravity. Stephen Hawking proved it.